And we came up with relationships for those four kinematic equations, d equals VIT plus half AT squared, and the other three. Now we're going to do the same thing we did before, except instead of looking at displacement time graphs or position time graphs, we're going to look at velocity time graphs, and we're going to see what we can get from them. And for obvious, well, I hope it becomes obvious. We're going to see why this is useful. So, just a bit of review. For the dt graphs, the main thing that we pulled off a displacement time graph was what? There was one big relationship that we pulled off that graph. What was the one big thing we were able to use our dt graphs to do? I'll ask it a slightly different way. We figured out the slope, and once we figured out the slope, what did that give us? The slope of a dt graph. No, it did not give you anxiety. What does it give us? It's funny though, I like it. The slope of a dt graph gives us the velocity of our object. Okay? The speed at which this thing's moving. So we looked at, and then we did the instantaneous velocity there as well. So if I had a slope that looked like this, you were able to tell me a few things. You were able to tell me that the velocity was positive. You can tell me that the velocity is constant because the slope's not changing. Or if I gave you something that looked like this, you were able to tell me that this thing was moving in a positive direction and accelerating. It's increasing because the velocity that it's getting, the graph itself is getting steeper as it goes because slope is connected to velocity. The steeper the slope on a dt graph, the higher the velocity, and if slope increases, then speed's increasing as well. Velocity time graphs are similar, and the only way that you're going to be able to tell the difference between the kind of graph you're reading is by looking at the axis. So here is one. Here is a VT graph, and the important piece to identify is that there. I know it's actually easier to read on the video than it is going to be to read in person, but it's a little bit mangled. Manual, you can go to the washroom now if you want. Velocity in meters per second north, and our x-axis here is time. So the first thing we can do with a VT graph is instead of finding slope to find the velocity can just be read off of the axis at any given time. So at 2 seconds, how fast is our object moving? Well, I've got a VT graph in front of me, so I'm just going to go down here to 2 seconds, and then I'm going to go to wherever the line is. How fast is our object moving? Because this is a VT graph. Yeah, you just read it straight off there. The velocity here is going to be 30 meters per second north. Remember, velocity is a vector. We need the distance and displacement. Velocity is a vector, so we need the magnitude and the direction, or the two words that I wanted there. And so there it is, 30 meters per second north. At 6 seconds, how fast is our object moving? 6 seconds, I just go along my time axis over here to 6 seconds. How fast is my object moving? Cool. Either we're going to quote that as negative 10 meters per second or 10 meters per second south. If this is going to get shoved into an equation, obviously you're going to want to use that negative. But talking about it with just words and language, we're able to look at this piece and talk about it as far as 10 meters per second south. Now, looking at this graph, what can you tell me about what our object is doing? If you had to describe the movement of our object using this graph, what would you say? Okay, so for this chunk of time, we've got a constant velocity. Okay, then what happens? Okay, so he starts to slow down, but what's happening? What did you say, Zaid?
He's still going north until it hits 0.
So from this, for this chunk here, we're slowing down. I'll say, but moving north. No, he's still moving positively. My velocity is still positive. So my motion must then still be positive. So how do you know he's slowing down, Zaid?
Because your meters per second is going down.
Because our meters per second is going down. I was at 30, now I'm going down to 0. Well, that's interesting. That suggests something, a relationship that might exist between velocity time graphs and slopes of lines. And we'll find out more tomorrow. Have a great day, guys. We'll see you later. Yes. I would be more than happy to.